Hello and welcome back. We'll continue to look at this question, seeing if Best Actress winners are younger than Best Actor winners on average. And we approach this in the same way that we usually do. What we're doing is we're comparing the differences and seeing if these differences are going to be on average equal to 0, or if they will be negative or positive, meaning that the actresses will be younger or older than the actors. So our claim is that the Best Actress winners are younger on average than the Best Actor winners. And if we call mu d the mean age of the actress minus the actor in any given year, symbolically we're claiming that mu d is less than 0. As in, if we subtract a bigger number from a smaller number, we should get a negative number here. So the null hypothesis is that the average difference is going to be equal to 0, or the mean difference is equal to 0. And our alternative hypothesis is that the mean difference is less than 0. Our significance level in the question was 0.05, and we were able to plug this into StatCrunch and come up with the following. We found the test statistic, and the p-value associated with that test statistic was in fact bigger than the significance level. So that means that the 5 matched pairs that we found were not unusual, so we can't really reject H0. So there was insufficient evidence to conclude that there is a difference in ages. What I quickly want to do is come back to the StatCrunch and show you one other way of doing this. In statistics, we can come down to t-stat, and we can do paired statistics. Rather than what we did before was just find the differences and run a hypothesis test of the differences, we don't have to find the differences explicitly. We can do a paired hypothesis test. So our pairing was going to be the actresses in the ages of the actresses in column 1, the age of the actors in column 2, and our hypothesis test was that the difference between, or the mean of the differences was equal to 0, and the alternative hypothesis would be that the mean of the differences is less than 0. And when we compute this, we can see that we get the same t statistic, our test statistic, and p-value that we had before. So both ways work. If you want to do find the differences and do a one sample test, or just go straight for the paired test. The other way of doing this is to use a confidence interval. And so with this confidence interval, I'm just going to block this off for a second. With a confidence interval, I was doing this slightly wrong before, so I want to correct this. So our significance level, alpha, was 0.05. So what this is referring to, because we have a one-tailed test, our alternative hypothesis is just that this is less than 0, so that's only one tail. This is referring to the area down here. However, with the confidence interval, we also have to take into account this area up here. So this is going to be 0.05, and this will be 0.05. So our confidence interval, our confidence should be a 90% confidence interval. So 90% confidence interval, and we can find that just by going into StatCrunch. Again, we can go to stats, t-stats. We can either do one sample with the differences, or I will do the paired data. So we have the actresses and we have the actors. We are going to perform a confidence, going to create a confidence interval, and the confidence interval is going to be a 90% confidence interval. The 5% or the 5.05 significance level on the left and on the right. And when we compute this, our confidence interval stretches from negative 24 up to positive 4. So if I'm just rounding quite heavily here, but our confidence interval will stretch from minus 24 up to positive 4. And we can see that 0 is inside of the interval. Which means that it is possible for the difference to be 0, which means that I can't conclude that there is a difference in the ages. If 0 is in here, it is possible that the ages that the difference in ages could be the same. So let's do one more example, and I'll also go through a confidence interval and a two-tailed test. So in this example, we have some households that recorded the weight in pounds of how much paper they discarded and how much plastic they discarded. And we just want to use a 0.1 significance level to test if there is a difference between the amount of paper they discarded and the amount of plastic they discarded. So there isn't really a claim here. So our null hypothesis is simply going to be that the difference in paper and plastic is going to be 0, is that there is no difference. And the alternative hypothesis is that there is a difference. So the difference, the mean of all the differences is not going to be 0. And then we'll just need to calculate our test statistic, our p-values, and our confidence interval. So let me pull up the stat lab. So we have all of the households. There's numbered 1 through, I think it's 30, and all of the paper that they discarded and all the plastic that they discarded. So if we come to statistics, down to t-stats, we'll do the paired data. Here we want to be a little bit careful. We're looking at the difference between paper and plastic. How much paper did they throw away? How much plastic did they throw away? And we'll do a hypothesis test first. Our null hypothesis is that the difference is going to be exactly 0, that there is no difference between the matched values. And the alternative hypothesis is that there is a difference. Now, we're not testing if it's going to be bigger than 0 or less than 0, as in more paper is thrown away than plastic, or more plastic is thrown away than paper. Just, is there a difference? And then we will compute this. And we get the following. Our t statistic is going to be 2.432. And our p-value that we calculate is going to be 0.021. If we just round it to 3 decimal places, 0.021. This is less than the significance level. So if there were no difference, this would be highly unusual. So we will reject H0, as in it doesn't feel like that there is that the same amount of paper and plastic is thrown away. So our conclusion is there is sufficient evidence don't know why I capitalized evidence, but oh well, to conclude there is a difference in the amount of paper and plastic discarded. Okay, so the conclusion is that, yeah, the null hypothesis is going to be false, that the difference between the paper and plastic thrown away by any household on average is not going to be 0, that there is going to be a difference on average. So now we need to construct a confidence interval. And the confidence interval that we're going to construct, again, when we look at this, we have our t distribution here. It's not quite normal, this is why we're using t. And this is a two-tailed test, and our significance level was alpha. But because this is a two-tailed test, that means that alpha is spread apart over both of these. So the total here is going to be 0.01, meaning that there's 0.05 on the left-hand side, 0.05 on the right-hand side. So what's in the middle is going to be 0.90. So we want a 90% confidence interval. So we can come back to StatCrunch. We can come to statistics, t-stats, and we have some paired data. And then what we can do, we're looking at the difference between paper and plastic, and we want a confidence interval that's 0.90. We want 90% confidence, and we will compute. And we now have the upper limit and the lower limit. Let's round to 2 decimal places, so that's 0.40 and 2.26. So 0.40 and 2.26. So we see that 0 is not inside of this confidence interval, and furthermore, all of the values here are positive. All values are positive. So this tells us a little bit of information. Since mu d was going to be the amount of paper discarded minus the amount of plastic, and all of these are positive numbers, that means that more paper was thrown away than plastic. So we can say that there is sufficient evidence to suggest more paper is discarded than plastic. And this is a benefit to using the confidence interval. All of the numbers between 0.40 and 2.26 are positive, meaning that this average, this mean, which is going to be the difference, the mean of all the differences between paper and plastic. Since that's positive, this would suggest that paper is going to be bigger than plastic, as in more paper is thrown away than plastic. So we can draw this conclusion, which is a little bit more than we could say with just looking at the p-value.